Hi, welcome to our lecture on statistics. Statistics can be divided into two segments: descriptive statistics or inferential statistics. We're going to begin with descriptive statistics, and as the name infers, descriptive statistics describe a whole population of objects, individuals, or other things that we want to understand some numerical characteristics. For example, we might be interested in characteristics of the population of the entire United States, or the number of pages in the U.S. Library of Congress, or some other thing that we might be interested in describing numerically. Now, one way to describe a population would be to list all of the numerical values in that population. So in our example here of the heights of all U.S. men, we would list 5'7", 5'9", 5'10", 6'2", etc. And you'd have a database of over 150 million entries. Or we can also list some summary characteristics like the mean or average or standard deviation that give us some summary indication of what that population actually looks like. So, as I mentioned, we'd have two numbers that describe this whole population of 150 million, and those will give us some idea, some summary idea of what that population looks like. The mean of the population is the average of all the individual items and values, and is represented by the Greek letter nu. So the formula for the mean is for nu here equals the sum of xi, as I varies from 1 to n, divided by n. So if we had 10 items, n would be 10, and this equation up here would be the sum of those 10 items, and that would be the nu, or the mean. The other very important statistical characteristic is known as the standard deviation. It's a measure of how variable the values of a population are. How much are they? What are the extremes, and how much do they vary from one to another? To calculate the standard deviation, we find the deviation or difference of an individual data point from the mean, nu, and then square it, and then add those squared deviations for all the data points, and then divide by n, and the result is the variance, which is the standard deviation squared. So here are the formulas for both the variance, and really all the standard deviation is the square root of the variance. And so what we have here is the differences between nu, the average, and the individual data points squared divided by the total population. Now, why do we square these differences? If we didn't square them, they would come out to 0, because some will be less than the average and some will be more, obviously. So once we calculate this, then the simple square root gives us the standard deviation. Now, there are several other possible measures for deviation, including simply squaring. Instead of squaring, we could sum the absolute values or take them to the 4th power. However, standard deviation is very special because it is a parameter of normal distribution. Now, normal distribution is probably the most important probability distribution that we have, and we're going to cover that a little bit later. So how is the mean and standard deviation useful? Well, let's take an example. We may find that the mean and standard deviation of heights of men in the US is 5'9", and there is a 5-inch standard deviation. Whereas in adult Dutch men, the height is 5'10", and the standard deviation is 2 inches. So on average, you would find Dutch men taller, but you'll find more variability in the U.S. population of adult men. So let's say you were walking down the street in Los Angeles. You know, the men might be a little bit shorter, but you're going to see a lot different. Some will be shorter, some will be taller. Whereas if you were walking down the street in Amsterdam, the men would tend to be a lot closer in height, but on average a little bit taller than the men in Los Angeles.